Welcome. This video is talking about the angles of our regular polygons. So we're going to have two types of angles, interior and exterior, and then find the relationship depending on what type of shape it is or what type of polygon. First thing I want to do is review what regular means. In our sense for geometry, not in real life, regular means all the angles and all the sides are congruent. So we have special names for those. It's still a triangle, but we call that an equilateral triangle. An equilateral and equiangular quadrilateral that are known as the square. We have a regular pentagon here, hexagon, hepta or septagon. So we just have to make sure that all of the angles and all of the sides are congruent. And we actually know or can locate certain measurements of them. So for an interior angle, first, we want to be able to identify which one is an interior angle. The interior angles are obviously on the inside here. It's almost if the sides were to pinch together. Right, that one is 90. So these that I'm labeling right here are all interior angles. So don't go outside the figure, don't go into the center. Okay, we have a name for that. That's going to be a central angle. But it has to be a relationship with these two sides. Now, what we can do, if it's a regular figure, we can actually find out how big these are. Like I just did in the square, I put a 90 degrees because all of us kind of know that one. But if it's a different shape, when we get to pentagons and hexagons, we can see they're all supposed to be the same, but how big are they? Well, what we worked on before is we can find the sum of all of them, whether it's regular or not regular. So if I find the sum of all of them, which if we remember is 180 times n minus 2, where n is the number of sides, I can find what they add up to. So in a triangle, okay, that adds up to 180 degrees total, quadrilateral 360, so on and so forth. So if we go 540, 720, so on and so forth, you can figure those out. But then think about how can I find each of them? Well, if each of them is supposed to be equal to themselves, really I'm just dividing by how many there are. That's the goal of division. So I'm dividing by n. So this is how to find each individual interior angle. So I can find a couple for you. For example, if I take 360, the sum of it, and divide by those four sides, that's how I'm getting each is 90. But let's go on to the pentagon. For example, in the pentagon, I said it was 540, but I'm going to divide that by 5 now, 5 equal angles. If I divide 540 by 5, that actually equals 108. So each of these is 108 degrees. If I take the 720 in my hexagon and divide it by 6 equal angles, each of these is 120 degrees. So I can find each individual by just taking the sum and dividing by how many there are. Another type of angle we're going to talk about is an exterior angle. So as before, or like before, we have to be able to identify it. That requires a little work from you. For an exterior angle, obviously it's going to be on the outside, but it's really going to be dependent on how you draw it. So we have to be very, very careful with this. To draw an exterior angle, I have my little line tool up. What I'm going to do is just extend the side. So right here, I'll label it in a second, that's my exterior angle. Now we might ask you, or homework might ask you, test something like that, to find those exterior angles. Make sure you go in the same direction. I'm going to extend that side and create another exterior angle. Extend this side, create another, and I just work my way around. It is a pentagon. So just like there's 5 interior angles, there are 5 exterior angles. Now, since it's a regular pentagon, or I'm saying it's regular, I should have it marked, sorry. All 5 of those angles are the same. So I'm going to draw those, but while I'm drawing these, think about if those are all equal, I wonder how big they actually are. So if I go to my hexagon now, I'll show you, it doesn't matter if you go clockwise or counterclockwise, just make sure you extend that side. So we have 6, Yeah, we'll say good enough for now. 6 exterior angles. And we want to think about how big they are. So I'm going to give you a couple strategies and you can pick what you'd like. And we're going to think about or use what we did before. If I know a pentagon had an interior angle of 108 degrees, well, think about the relationship here. My exterior angle is an extension of that side, and I just cut it. These become supplementary. They become a linear pair or a straight angle. So what I can think about is if I know the interior, I can find one exterior because it has to add to 180 degrees. So that one's 72 degrees and all the way around. Now it's going to be different in a hexagon because I have more of them, but let's think about this. I have 120 degrees on the inside or in the interior angle. The supplementary to that is, or the supplement to that is 60 degrees. Now I got 60, 60, 60, 60, 60, 60, so on and so forth. That's 72, 72, 72, but I want to find a relationship there. There's actually something interesting. I have 6 60s. Think about what that adds up to. 6 60s is 360. 5 72s is also 360. So your book has something interesting if we're going to find the sum of the exterior angles. Just like we find the sum of the interiors, we can find the sum of the exteriors. So on the in 8.2.1 or 0.3, sorry, they have this little E tool here, and what it has is the sum of the exteriors, the A, B, C, D, all the way through F, and they're all different. So this is even works for non-regular shapes here, and it has the sum of them as 360. Now I can change the shape, I can change how big it is too, and it keeps those angles the same. So that's still 59, that's still the orange 62. And if I bring this shape together, it keeps the exteriors all the same. Dun, 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 dun. What happens is those angles all come together to form a circle if I just make it infinitesimally small. So what this is telling us is there's actually a really, really, really nice relationship for the exterior angles. The sum is always 360 degrees. No matter how many there are, no matter how many sides the shape is, whatever it may be, 100 a gun. Awesome. It still has to add to 360 degrees. So that's our intro of that. We have the sum of interiors. We can find each individual interior. We can find each exterior, and we can find the sum of the exteriors. So what type of problems will we ask you? So I'm going to go to a couple problems if you want to watch that. This is from the book 8-27, so you can try those as well. So it says Gerardo drew a regular polygon that had an exterior angle measuring 40 degrees. So I'm just going to draw an exterior angle of 40 degrees, and I might have the shape, wrap around. Who knows how many sides it has. But that's the idea here, that we want to be able to know what an exterior is and find the interior. Then I can find how many sides the polygon has. What's the name for that polygon? So if the exterior is 40, yeah, I could find this as 140, but I'm going to show you what it would take then. And then I have to know the sum of all those, and there's a much easier way. If this angle is 40, however many there are, that has to sum up to 360. So it's like 40 plus 40 plus 40 so many times is going to have to add up to 360. So if I just take 360 divided by 40, I know n is 9. And that is a nonagon. So having the exterior angle is actually, it's probably more advantageous than having the interior angle. So I also have a polygon that has an interior sum of 2520, 2,520 degrees. How many sides does it have? Well, now I don't know the interior. I know the sum of it, and then how many sides. This is a little more challenging, that I know the sum of the interiors. So the sum of the interior equation is 180 times n minus 2. So what I can do is I can divide by 180, which I'll do on my calculator here. 2520. That's 14. So that would say 14 equals n minus 2. So that's pretty easy to solve from there. I just add 2. I have n equals 16. It's a 16-agon. Now, quadrilateral has 4 sides. What's the measure of each of its interior angles? Now, that's got to be careful. It just says a quadrilateral. So if you went to, well, it's 90. Got to be careful. It's got to be a regular quadrilateral. So I cannot solve that one. And then lastly, what is the measure of an interior angle of a regular 360-agon? So 360-agon, that interior angle's got to be pretty wide if it's going to be able to make it all the way around. It's pretty much a circle, I'm sure. So I got a side like that. It got 360 sides. Now again, this is where I could find the interior. Each interior though is going to be 180 times 360 minus 2, all divided by how many sides? 360. That's one way. But another way is thinking, and they're asking, is there more than one way? Well, if this is the exterior angle, let's call this x. Well, 360-agon, I know how many sides, so x times 360 equals 360. So the sum of the exteriors has to equal 360. I'm going to take the, how big the angle is times the number of sides. That was our equation from sum of the exteriors. We'll just divide by 360, x equals 1. The exterior would be 1 degree. That makes this 179 degrees. And if you calculate that in your calculator, it gets you the same thing. So there are 2 ways. My personal preference, I like knowing exteriors because it's a nice, just one-step division. But there are definitely ways if you know each interior equation as well. Good luck. Hope this helps. Keep on keeping on.